So I'll be explaining heap and heap sort algorithm. So firstly, let's understand what is a heap. A heap is a binary tree represented as an array of objects with the conditions that it is essentially complete and the key at each node is greater or equal to the keys at each children nodes. This in summary means the parent is always bigger than children. Another way we can define a heap is that a heap can be defined as a complete binary tree with the property that the value at each node is at least larger or small or smaller as the values at its children nodes if the children exist. This is called the heap property. So this second definition is making us to understand that there exist two types of heap where the value at each node, which is can be the parent node, might be larger than its children, or the value at the parent node might be less than the children. So when the value at the parent node is larger than the children, it is a max heap. And so we have this example. And then when the value at the parent node is smaller than the children, what we have is a min heap. This is an example. So when is a binary tree complete? A binary tree is essentially complete when the tree is completely filled on all levels, with a possible exception where the lowest level is filled from left to right and some rightmost leaves may be missing. So let's take these two examples to understand. The first one, the first diagram here has first we validate it as a heap. Firstly, because the parent nodes are larger than the children nodes and it is filled from left to right. A rightmost node is missing, but it doesn't mean it's not a heap. As long as it is filled from left to right, it is a valid heap. Now, the second example over here is not a heap. We do not validate this as a heap because parental dominance is violated at root 5. 6 is larger than 5, so this is not a valid heap. Now, let's see the methods of construction for constructing a heap. The first, we have the top-down construction. To understand this, let's take this example. Construct a heap for the list 297658. The first node is 2. So we start with 2 as our root node. And then we insert 9. We insert 9 below 2 as, as though 9 is a child to 2. However, 9 is greater than 2. So 2 and 9 must swap positions. We are building a max heap. We now insert 7. 7 is less than 9. So it will take the second child of 9 at the right position. We now insert 6. We insert 6 at the left. From left, we insert from left to right. So 6 takes the position at the left of 2. However, 6 is greater than 2. So 2 and 6 must swap positions. Now we have here the bottom up heap construction. Here is an algorithm to demonstrate how the bottom-up heap construction is done, performs. However, to better understand this, we will first of all understand an example and then we will see how this works. Now, from here, this slide is to demonstrate that the process of heapify is when we are building the valid max heap, when we are taking the root that is found at the node but is smaller. So we have to bring it down by continuously swapping with the larger nodes until we have the largest node at the root and the parents' nodes are larger than the children. This process of taking the smaller node at the root, bringing it down, is called sift down or bubbling down. And while we are doing this and building a heap, this is called heapify. This process is called heapify. So here we have a few properties of a heap. The height of a heap is floor L and floor LG of N, meaning that for we will see in an example. How do you know how to construct a heap the height? So we take the log of the N, which is N is the total number of nodes in the heap. Now the root node of the heap has the highest priority item. We will use, especially when we'll be conducting the heap sort algorithm, we'll have a lot to do with the root node, which will make it a top priority item. Now, a node and all the descendants is a heap. Uh, Moving on to the heap sort algorithm, which is a core concept here. So in the heap sort algorithm, the process summary is that the heap sort is sort an array by first building a heap data structure to build a valid heap. For building a max heap, we make sure all the parents are larger. For building a min heap, make sure all the parents are less than their children. And then we repeatedly remove the largest or the smallest and place it at the end of the array. So if we're trying to sort an array using the heap sort algorithm, this is the process we follow. All right, the performance is consistently O n log n in best case, average case, and worst case, and it has the following characteristics. So the core step here is heapify. Now, having established that, let's take this very interesting example to understand the heap sort algorithm. Here we have to sort this array. This is an unsorted array, and the task is to sort it in ascending order using the heap sort algorithm. First, we transform the array into a binary tree. We have the first node, which is 12 at the roots, and the children 4, 4, 10, 9, 1, 7 from left to right. All right, so we'll start from the bottom to build a valid max heap. 9 and we start with 7. 7 is less than 10, so this side is fine. Now, compare 4 with its other children, 9, and with its other children, 9 and 1. We see that 9 is greater than 4, so they must swap positions. From there, we have this. We check if there is any parent node that is less than its children. No, there is not, so no swaps will be performed. The resulting array will now be such as 12, 9, 10, 4, 1, 7. So now this is the resulting array, and we have the largest item at the root node. We can agree that this is a valid max heap. What do we do now in the heap sort algorithm? We take the root node and place it at the end of the array. So that is why you see this number in orange, 12. This is the only sorted part of the array. And whatever element was here must swap positions to 12. That is why 7 has come to position 1 and 12 has taken its position. Now we'll continue. 7. Now, which elements will be the new root node? The rightmost element according to the heap sort algorithm. So the element at the rightmost comes to the top. We have 7 here has come to the top. How do we heapify? Compare 7 with its children nodes. 10 is larger than 7, so they must swap positions. I don't get it. So after the swap between 7 and 10 is done, 10 is now at the root node. 10 is larger than all its children elements, and Every parent is larger than the children, so there's no further swapping to be done. Now we remove the root node and place it at the end of the array. So after 12, we now place 10. 10 takes the second position from the end and swap position with whatever was currently there. So 1 that was currently here swaps with 10. The swap takes place, 1 comes to the roots here and 10 comes here. So the resulting array is 1974. 1 also comes here because the rightmost element comes to the root. So you can see it from the array or from the binary tree. The rightmost element comes to the root, or whatever was at the original position here swaps the same thing. We continue. So we continue our sorting. We now move on to this. So now we have 1 as the root and 9 and 7 as the children. Both of these numbers are larger than 1. However, which of them is the largest? 9 is the largest. So 9 must swap positions with 1. Okay, here it is. 9 has to swap positions with 1. But 4 is still larger than 1. So 4 and 1 swap positions. Now we have this. The root node is the largest item. We do the same thing. We add it to the end. We add it at the end of the array, and whatever was here must swap positions with 9. So we have this part of the array is sorted, this part is the unsorted. All right, now the resulting array is 147. We continue our heapify from there. So we see that 1 is at the root node. However, 7 is the largest amongst its children, so it will swap positions with 7. From here, no other swapping can be done, so 7 is removed and placed in the sorted array, while the unsorted section numbers are still 1 and 4. One takes the position of the root node because it is the rightmost element, and it has also swapped positions with 7 here. However, 1 is less than 4, so we know the swapping must be done. So 1 and 4 swap positions. 4 is the root. 4 is taken out, placed in the sorted, and then what we are left is 1. So 1 is the only node left, and so it comes to the front. And so now what we have is a completely sorted array in ascending order. The original array was this, but now we have successfully sorted in ascending order using the heap sort algorithm. Now there is now we can see that the heap sort algorithm is similar to selection sort, but with a difference. So with selection sort, the algorithm works by splitting the array into an imaginary sorted and unsorted boundary. It explicitly performs a linear scan through the remaining unsorted elements. It goes through each element to look for the largest item. So it takes one element, goes through each of them, searching for, is this element I have bigger than these elements in the array? If not, is checking each of them, or is the smallest element, or if we are arranging in descending order, then we'll be checking for the smallest element. But he has to look at every single unsorted element during every round. Now, from this, you can understand that looking at every single unsorted element during every round is time consuming. So the heap sort is significantly faster than the selection sort. Thank you. I've come to the end of my presentation.